Hey everyone, this is your friend Venkat Ramakrishnan at Software Testing and Quality Talks, bringing you the next episode. Today we have Tom Binns from Leeds, England. Tom Binns is a contractor in testing services in DevOps. I met him in social media during a discussion on DevOps. He had been a consultant for most of his career. Tom has worked on multiple domains. Currently, he is working on testing backend of complex systems with very little UI, managing small services that interact with a messaging queue or a HTTP connection. Welcome, Tom, to the show.
Hi, Venkat.
Let's talk about testing in DevOps. You mentioned that you get the customer feedback, right? When you are committing changes. So do you get the customer feedback every time there is a change, or does the change happen because of something else other than customer feedback? How does it work?
Yes, I mean, there's a number of elements to that. So, I mean, first of all, there's the reason why you're doing that change. If that change is due to some customer feedback that you've had previously, it may be one particular sort of customer that's raised it, or it may be something you've noticed through your sort of your monitoring and your sort of observing of the system that something needs fixing or changing. In that case, it's very easy to know whether it's fixed the issue or whether it's made it a little bit better anyway, because you can either go back to the individual customer, or you can look at your metrics, your sort of observability of the system, and find out whether that has been resolved. For other things where the change may have just come through the company rather than the direct from the customer,
Okay.
That is a bit harder. So the essence of DevOps is that we're responsible for everything. That single team has the full understanding of what the software is and who the customer is and how they're using it and how the system is being used. So that team should understand sort of what impact that change is going to have. There's a few ways of monitoring that and finding out whether it's worked. I think one of the most common ways I've seen and what we've done is via sort of canary deployments.
Okay.
So for instance, we wouldn't release, so the code has been deployed and released, but only to a subset of customers. Now, on one particular service that I worked on, these customers in the canary deployment set were self-selected. So basically, we asked all of our customers, would you like to be part of the beta program, basically?
Right.
And the ones who said yes, they get a few special treats, but they're part of this beta program. When we make changes, they go to that team first. So that team are aware that these changes are coming constantly. They're also motivated to respond to us with any sort of either positive or negative feedback. So if they like the change, if they don't, they will contact us very quickly. So what we would normally do is, depending on what change was going out, we would do a canary deployment to them. And I think generally for a small change, it was automated that after 2 hours with no issues, it would automatically be rolled out to the full user base, full customer base.
Wow. Okay.
So along with that beta program and the actual feedback, we put a lot of work into making the system observable so we could see what the system was doing and we could interact with it and query what the system was doing in real time. So when we make a change, we can see, so if we make a change to, I don't know, the login page, we can see immediately if customers are spending more time on that login page. For instance, we may have made it more complicated, so it's taken them longer to log in. We can see the rate of failed logins, attempted logins, all that sort of thing. The validation, has that failed? So, for instance, I mean, make a change to, this is always a horrible change to me, but making a change to password rules. I mean, that's always a horrible thing to retrofit afterwards. But if we'd made that change and pushed it out, we can see through the logs and the monitoring in live real time what effect that's having on our customers. So that's not necessarily getting direct feedback from them, but we can see what they're struggling with.
From the traceability perspective, from the requirements to production, in terms of the requirements, essentially a change means you are dealing with a new set of requirements, correct? If I'm not wrong. So as a tester, do you review this new requirements in the light of, say, performance, security, and the other areas, right? So basically you are going to look at the thing in a new perspective. In the traditional software development, we used to have the requirements right at the front, but in this case, when we are in the production and we are doing the canary release and things like that, the requirements are getting input from the fag end. Now, how do you track these changes to the requirements? Do you have the requirements noted down somewhere in terms of how the system should behave, and then do the traceability to the future versions, or how does it work?
Yeah, I mean, if you want a polarizing opinion, ask that question on Twitter. That ask a dozen people and you will get a dozen different answers. Requirements and traceability and all that thing is really difficult to manage. The way I see that is that a requirement is a point in time. It's not an overriding requirement. It's right now, the change I'm making is that this system needs to do this. What I will do at that point is, or what the team will do at that point is change the system to match that requirement at that point in time. A test or multiple tests will be created to validate that the system does what that requirement states it should. After that, I no longer care about that individual requirement. I have a set of tests that form an executable specification. So if I want to know what my system does, I can see because I can look at my tests and they will tell me what my system does. But I'm not that bothered about where that initial requirement came from. So this is sort of, I suppose, having the luxury of not working in a regulated field. I think it is a bit different if you work in finance and definitely medical. That traceability is a lot more important. But for most fields, that traceability, I think, causes more problems than it solves. So I've seen a lot of teams, for instance, when they create a test, they will link it back to a Jira ticket. I mean, you can't be agile without Jira, right?
Yeah.
So they'll link it back to a Jira ticket. But we're agile, we're constantly taking on feedback and changing things. That's how we work. So if a later ticket then changes that requirement, so the initial ticket might say there are two fields, one A, one B. A ticket may come in a few months and says, actually, we want to change B to C. What requirement do we link that test? The test, there are two boxes on that page. It gets really complicated because requirements are constantly changing. There is no one single requirement for an item.
When we say we analyze the requirement, there are two parts to it. You already have the tests, right, which you execute when there is a change in the requirement. You said that you have the test cases and you execute them, you automate them, and then you execute them. That's fine. But there is also this human element involved in making sure that, are you executing the right set of test cases? Are you using the right set of data? There is so much of human analysis that needs to be done, because if you keep repeating the tests with wrong data, or if you are not doing the right set of tests, then it is not bound to expose issues outside the area that you are trying to explore through the tests. So I see that needs to be a human element involved, in addition to the automation scripts, which has to make sure that you are executing the right kind of scripts with the right data to expose issues. What do you think?
I mean, definitely. At any point, you want a change to have been looked at by a human. How much that human has to look at depends on what type of system you're actually building, for instance. So most of my probably last 5 or 6 years has nearly 100% been backend systems. So there's been very few actual UIs. So there's been a lot of messaging. So, RabbitMQ, Kafka, that sort of thing, HTTP, of course, but there's been no UI. So there's been a number of smaller services, not necessarily microservices, but smaller services that interact via messaging or direct HTTP. Those smaller services are not complex. It's very, obviously with testing, there is no such thing as exhaustive testing, but a combination of small services that don't do very much, good unit tests, good integration tests, contract testing is vital when you've got smaller services that interact with each other.
Right.
if you have all of those three things, then there's not much for a human to do. I'm not saying you don't need a human, but there's not much for them to do. That human could be a developer, either the one who wrote it or a different one on the team. And it's a case of, for a messaging system, so I'll put a message on, see if it's worked, mess about with the data, have a look at it from a holistic point of view that an automated test is never going to. But there's not that much that could go wrong in a small service.
Got that. So in the microservices area, I understand what you're saying, but there are complex systems, let's say, for example, compilers and things like that, where even a small change that you make in a module, a whole lot of automation scripts needs to be executed to make sure that things are. Many of the modern software testing methodologies and modern software development people agree that this mob programming or pair programming is not for every kind of software. You might have to spend several days or even weeks to run those tests because it's a very complicated thing. Not that I'm saying they are ubiquitous, right? So I'm not saying that they are everywhere. I'm just saying that those kind of software exists. Consider SAP. I mean, it's so complicated and you have to write specialized test cases for that. So let's move on to the pair programming, right? So you mentioned about pair programming with the developers to explore the code. How comfortable are you to identify issues in specialized areas like performance, security, etc., just in the code? Let's assume that the software tester is very well versed with the programming language of the product code. Let's assume that for a second, they are in par with the developer. Let's assume that. Even then, do you think it will be really effective to deduce issues in performance, security, and specialized areas like that with just looking at the code? Or don't you think some kind of black box testing would be required?
It's going to be a little bit of both, generally very useful sort of later on. But yeah, I mean, initially when pairing with a developer, there are things that you can spot immediately that are going to have performance issues. I was pairing with a developer. I mean, this is a good few years ago now, working on a system that used Akka, or at least the C# version of Akka, which basically is for every request that comes in, it spawns an actor, and that actor then goes off and does whatever that actor does. However, with a lot of messages, you end up with a lot of actors. Those actors can spawn other actors. We were initially building the first sort of POC of this system, and it was very easy to see with the number of messages that we expected to come in, that if we carried on doing it like this, we would need hundreds of gigs of memory just to process them. That was just looking at the code, but it was obvious to see. I have seen developers, when pairing, use unsafe sort of strings and things from databases, so that they'll just use them directly, or they will use string interpolation to build a SQL query. I mean, that's a major red flag. Rather than using parameters, they'll build a string using unvalidated strings from input or from the database, right, or from somewhere. And that's a major red flag. So you can spot these things whilst you're writing code. And I think pairing, whether that's two developers, a developer and a tester, it doesn't matter. It's that fact that you're working with somebody that helps you spot these things. Because it's very easy when you're just by yourself to be blindsided and just, I'll fix it later maybe, or you don't even notice you're doing it. But having to explain yourself to somebody else makes it so that these issues don't happen. They're vastly reduced. But that's only one part of it. The next part of it is after that's been created. So you mentioned security and performance. Those are two vital aspects. So generally the way I work is every small service has its own performance pack. So every change to that service, it's going to have as part of the CI, it's going to have a performance test run against it. Now, that is fine for existing functionality that gets changed, but it does require it to be kept up to date. So if I'm adding a new endpoint to a service, I will need to add more data and more test cases to the profile, to the performance test pack. So it's not, it's something that still needs maintaining. It's not a magic solution, but these things can be done. But the thing is to do them as soon as possible. So if you can't catch them at programming time, catch them at build time. If you can't catch them at build time, catch them on integration time. What you don't want to do is wait until it's deployed to a full environment in order to be able to test, because by that point, there is a lot of resistance to change.
Right.
It's a lot harder to make a change when something's been deployed all that way.
Right. If we catch this in the requirements itself, to a person who has been well immersed in the system for a while, for example, a person who is testing the same software for say 4 or 5 years, they would be very well versed with what would happen if this new requirement is implemented, or what would happen if a new feature is implemented, and what are the touch points that will get affected because of this. I'm not talking about developers, I'm talking about testers, because, that would be the level of talent and the skill that they would have because they have been in the system for so long. So if they catch it in the requirements itself, that will be ultimate. But, things happen and we find out later. That's okay. Let's move on to exploratory.
Sorry, just before we go any further, just to sort of go back to that point.
Yeah.
A tester that's been in a project for a number of years is going to have an understanding of not just that individual system, but the system as a whole and how things are going to affect it. That some of the best testers I've worked with have not even necessarily been great testers, but they've had great domain knowledge.
Right.
And that domain knowledge is what has saved that project, or made that project a lot easier to work with. The trouble is, what happens if that domain expert is the tester and they leave? That team has relied on that one individual being the domain expert. If they leave and a new tester comes in, how many years does it take for them to build up that domain knowledge?
That's going to be
the person previously. So whilst teams can work really well with that one tester who knows everything, having a single point of failure is really dangerous. If we can spread that around the team so that everybody in that team understands the domain and can think that if this changes, what is that going to affect? Rather than just think, oh, I don't have to worry about that, the tester will pick it up.
Yeah.
Then you're a lot safer. Not particularly nicely, but I refer to it as the bus factor. How many people need to get hit by a bus before this project is doomed?
Yeah. Absolutely. So we should spread out the domain knowledge as much as possible. And it just gave me some idea. Maybe we can capture the domain somewhere and maybe help the testing. There are good old scripts that are getting executed for so many years, which has all the domain content. But when a new tester comes in or a new person comes in, they don't understand what the script really does, right? So those are the kind of challenges we usually face. Anyway, moving on to exploratory testing. You said that exploratory testing is not done in a good fashion, right? How do you think people can improve the exploratory testing? Well, first of all, what is your idea of exploratory testing? Is it the black box testing, or analyzing the whole system from the requirements, functional spec and design and code and things like that? What is involved in exploratory testing?
Yes, I mean, a lot of people will consider anything that a tester does around exploring the requirements and the domain to be exploratory testing. I don't find that particularly helpful to make it that wide. So for me, exploratory testing is sort of testing something that is actually working, whether that's interacting with an API or a UI, but there is something. Dealing with requirements is a related skill, but I think it's helpful to keep it separate. So ideally, the majority of this work is done upfront on those requirements. So although I wouldn't call it exploratory testing, it does need testing. So you have all these requirements that are coming in. You have to validate them to make sure not only do they make sense from a technical point of view, is this how we should be building it, but also from a customer point of view, is this what we should be building? Is this what our customer wants? So that is incredibly valuable to do up front on those requirements. As much as you can do there, it will save you time later on. But yes, exploratory testing is in the vast majority of cases always going to be required. I just don't believe it's as important as it once was. As services become smaller, as automation becomes better, the need for exploratory testing of a working system becomes lower. If that becomes low enough, there may not be enough work for a dedicated tester in that team, at which point the rest of the team has to take over and do that. I think it's one thing to say that a tester always needs to be there to do these things, but if a tester is in a team without that much work to do, they are going to become incredibly demotivated and not be a good tester. So, I mean, for the most part, teams I've seen, teams with a bad tester or an unmotivated tester are worse than teams that do not have any testers.
Yeah, I'm pretty sure that there would be other projects in the company to reallocate the tester to some other project, or find some other work for them. So should not be a problem.
I've also seen testers that are responsible for multiple projects. So they're the tester for maybe 2 or 3 projects. So that they're the people who do all the testing for those 3 projects. And the context switching is a killer. It's just really hard to do. I think it's fine to be a quality coach and help the testers, help the developers test in those teams. But being the person responsible for testing for 3 different projects is really hard mentally. Because you mentioned before about domain knowledge and understanding of the wider systems.
Yeah,
it's really hard to do when there are multiple wider systems.
Wonderful thoughts. Just before I go, I want to ask you about the domain that you work on, so that we can get a clarity on from what perspective your views came by, so that we can have a better understanding of your domain and your kind of work, so that we can appreciate your inputs.
Okay, so I'm a contractor, and before that I've been a consultant for most of my career. So I think for the last 10 of the last 12 years, I've been either consulting or contracting. So I've worked in a number of domains. I've seen good, I've seen bad, mostly bad. Not to say most teams are bad, but if they're hiring in consultants or contractors, they probably have issues. So I've seen a lot of teams, and I've seen a lot of different ways of working. As I've said previously, last 5 or 6 years has mostly been back-end of systems with very little UI. So most of my recent experience is teams building and managing small services that interact with either a messaging queue, or they have HTTP connections, either inbound or outbound.
Okay.
Individual services being very simple, the wider system being more complex. So in terms of when it comes to testing those things, most of the focus hasn't necessarily been on individual services because they're fairly simple. It's been the interactions between them. It's been testing of the system rather than the services. But that doesn't require, so that's more of an upfront thing. So you're setting those requirements, how these things deal with each other. Contract testing is, I've mentioned before, why every team that has smaller services that interact do not use contract testing, and I do not understand. If there's one tip I can give to teams, use contract testing. It will save your life. So yeah, back-end smaller systems is what I've mostly been working on.
Excellent. Thank you so much for your time. It was a wonderful talk, and it gave me a lot of perspective into the DevOps, and we will keep talking. And if there are future opportunities to discuss further on any of these areas, I would definitely give you a call.
Okay, thank you. It's been nice talking to you.
Thank you so much, Tom. Take care. Bye-bye.
Bye-bye.
All of those who listen to this podcast, thank you so much. Please stay tuned to my YouTube channel by subscribing to my channel, as I am in the process of bringing out regular videos on various aspects of software testing and quality. See you soon.